So let's talk about static. We've seen it many places, and we're going to see it a lot more. What is it? Well, static means we could use that method or variable without creating an instance of that object. It kind of lives with that class, but not with an instance of an object. Why would you ever want to have something that exists without creating an instance of an object? Well, sometimes we don't need to have a whole object to use something, or we want that field or that method to exist when that object is not there. We could also have it when it's shared between all instances of that object. There's many uses for static, and over the videos that we're going to have, we're going to learn more about it as we go through. But for now, let's learn a little basic of it. Static, in this case, you could see that a void main requires the method to be static. Why? Because the object start, the class start, has never been initialized. There's no instance of start. This main will exist without an instance of an object. This is what static does. Now let's try some other method. Let's go back to our person here. We have some fields here: name, height, weight, hair color. Actually, before we do that, let's see some other examples of a static method or a static field. As an example, if we type in math and we do dot, you'll notice that we have access to a lot of methods inside math, but I never created an instance of math. Why is that? Well, to be honest, if I wanted to get the maximum of two numbers, basically which number is bigger than the other one, do I really need to create an object just to compare two values? It would destroy a little bit of resource because an instance of an object will take space inside my heap memory, right? We don't want to waste space for no reason. And in this case, this method is self-reliant. It doesn't need more than having these two integers available to it, right? The same thing goes when I want to access a static value, such as, let's say, pi. If you notice, the moment I'm typing pi, you could see even the value there, right? This is the value of pi. Do I really need this value inside of an instance? No. In those cases, I'll make them static so that they belong to the class and not to an instance of that class, right? So if we hold down Control, we could actually click on this max method and we could see how it's being done. You could see the word static there. And all they're doing is basically saying if A is bigger or equal to B, we'll then return A, otherwise return B, right? Same thing goes with a class field, right? A static field is also called class field. If we hold down Control and click on pi, you could see here a value is written down. Well, obviously it's not the full pi, but you could see there's at least 10 to 15 digits, whatever amount double allows us to have. You could see over here the e, the exponent, the degrees to radiant, and radians to degrees. One other thing to notice here is that everything that's static, normally what we want to do is, well, normally when it's static and final, it depends on your companies a little bit, but what we want to do is have it all capitalized, and we want to use the snake case to to separate a word with another word. So degrees to radians, all capitalize, underscore to separate words, and in this case we want to kind of try, if we can, when we have static, we want to have final. It's a rule of thumb. You don't follow it to the word, but most likely you want to have something that's static and final, okay? Again, final, if you don't remember, it means the value of this variable cannot change. Now, let's go back here. So we had two examples of this. What can we do if we want to create it ourselves? So let's go back to person. Person is not a great example of what we want to do static. Maybe a good example would be like a student ID. Actually, let's go ahead and we're going to, well, I wanted to create that a bit later. let's try something here, okay? So at the top of this, I'm going to create something private. Always remember, we want to start with private, and if need be, a rule of thumb, if need be, we'll change it to public or any other more loose accessors. So what do we want to do? So we want it to be static. Do we need to be final? No. Maybe we could have a date. So I'm going to use the date object. And we could say let's say as an example, a great example that's being used all the time is when was it last created, right? And we could put that inside there. Now, the only thing I would talk about here is, again, if it's not final, we don't really need this capitalization. It might vary from company to company, but because it's not final, we could just keep it as last created. And again, there's a lot of rules that you'll see, like a lot of places, an old rule that might still persist because of the company's old history is you might do something, if it's private, you would do something like this, an underscore to represent it being private. Again, you'll get a sheet of rule sets. But for our case, let's say that whenever it's final, we'll make this capitalized. If it's not, we don't really care. And obviously, the last created for now is set to null. Yeah, so this is the default value. We could put it here so that we could see it. We could get a bit used to it. And whenever I create a person, we could say last created equals, let's say, date dot, do we get anything? We get instances? No. New date. And if I do Control Q, allocate state object, initialize it so that it represents the time at which it was allocated. So this, the moment we create the object, is going to be the current date, right? So that's good enough for us. That was Control Q to get the documentation. So whenever we create this object, we're going to set the last created value to the current date. Now notice this last created is static, while this person is an instance of the object. All instance of objects will get access to this last created, will get access to this static, right? Because it still belongs to that class. And obviously we could create a getter, so we could see what was the last value without changing it. So let's go ahead right under here. There's ways to create, sorry, there's ways to create the getters without actually typing it, because it's always the same thing almost. But for now, we're going to just kind of get used to doing this, because you'll notice eventually we'll modify the getters to kind of do certain things, and we'll talk about that a bit in the future. So for now, we get last created, and that's going to give us our value. You'll notice here I'm going to create a person, a person, and a person, and a person. And the moment I want to access that static field, we don't need an instance of an object, but we could also do that. Let's actually erase all of this. We don't need an instance of an object, but we could access it. So we could either say person. Well, here I don't have access to it. You see, I'm doing person, not an instance, but the class itself, dot. And you could see I only have access to two things. This is not good. Well, this is because my getter here is not static, right? So that's not accessible outside of my method, of my instance. So if I want to access to it, I could say, let's say person1 dot get last created, right? Because right now it's part of instance, the method itself, not the static. So again, that means this belongs to all three of them. They share the same value. So if I would have to print this 3 times with 2 and 3, you'll notice that all 3 times will get the same value because it's a shared value. So static is shared in this case because we only have one of this variable. Now, if I make that getter also static, right? Now made a method that belongs to the class, right? We have still access to it by these three, and you see there's like a little warning. We could put our mouse over it. And it's telling you that this method, the static member of this class, is accessed by a instance reference. Again, instance just means the new object. We could also now access it by saying person, this is the class, dot, and notice here, the IntelliSense is showing you, we now have access to get last created. And again, it will repeat the same thing. Now, the interesting part about this person get last created, unlike, let's say, these instance ones, the instance, if the instance doesn't exist, we don't have access to that method. But because it's static and because it's public, we have access to that static method, even though none of these objects have been created. None of these variables have been created. None of the instance of those variables have been created. Right? So over here, I'm specifying a class. Notice the capitalization. Normal variables are lowercase. So I'm accessing the class person, and I'm accessing a static variable, static method that's public. Now, if I run this, you'll notice it's going to be null at the beginning because it hasn't been set yet. And the moment I create a new person, that value has been added. Right? Now, I'm not sure we're going to see a big difference if I do this print between each one of these. Why? Because the computer is so fast and we're not seeing the milliseconds here. We're seeing the hours, the minutes, the second, but all of this is executed within a millisecond, right? If I do an infinite loop of this, maybe we'll see a variations. Actually, we could do that. You want to? No. Yeah, why not? Let's do a little infinite loop. So we're just going to do a while true. And the only thing we're going to do in there is we're going to create a new person. We don't really care about the name. And then we want to just print out the time. Yeah. So we're going to do person get last created. And because it's infinite loop and because it's going to go over many seconds, you're going to see the variations. I'm going to just do like 1 second, 2 second, 3 second. Now you could see 33, 34. Right? So every time an instance of that object is created, the value of that static field, last created, is going to change. Now, remember one thing though, that static method or static variables or static fields, right? Like this one, they do not belong to an instance. So if one of them changes it, it changes it for all. And static is important because later on we're going to see we're going to create these more complex structures, and we need to have access to something like this. All right. I'll see you guys in the next video.